Good morning. This is the relearning for the second standard on the thermal energy test. This standard had to do with dealing with the data from the two labs that we did. First, the thermal equilibrium lab, and then the food lab. The primary goal here was, can you use similar data to both graph and then make sense of that data? So the first part of the thermal equilibrium, this standard was graphing data that was similar to our thermal equilibrium lab. The relearning for this is that you need to take your graph and you need to fix it. If you need additional help, you either need to see me or you need to watch the relearning video on graphing from earlier in the year. I've linked that on the Hapara workspace, but you need to just take that data and fix that up. Correcting what you did wrong from the test. The first question after that was this question. It asked, was there in that graph more cold or hot water? And the key here, we have to understand that if there's more hot water than cold water, the final temperature of equilibrium is going to be higher than the average of the original two temperatures because the total energy is now more. If you have a larger container of hot water than cold water, you've got more energy than if you had more cold water than hot. Again, part of this is just picturing what is happening here. What is really going on? So if we're looking at three graphs like this, time is on the x-axis and temperature is on the y. And each of these we can see have three very different final temperatures. This will be the final temperature on the far right side of each graph. So an example in which you might have, I'm going to start with this graph C. So in real life, what would this be? Well, you have more hot substance than cold substance. And because that final temperature of equilibrium is closer to the original temperature of the hot substance. So what this might be a graph of is the temperature of soup, hot soup, and some ice cubes. So this would be, this dotted line in part C would be a graph of the temperature of the water of the ice cubes increasing in temperature and meeting the temperature of the soup. So there's more soup than ice cubes, and that final temperature is closer to the original temperature of the soup. For this part, I'd like you to think of two real-life examples of when you would have, for part A and part B, when one is meeting in the middle and another is closer to the cold temperature. The second part of the standard was which food represents, it was the data from the food lab and making sense of it. You all did a fine job on this during class, but I think some of you freaked out a little bit when you saw it on the lab, not really sure exactly what I was asking. So let's start by looking at this. If we're looking at, this is the percent of how much of a pumpkin seed is carbohydrates, how much of it is fat, and how much of it is protein. Same thing for Cheetos, what percent is carbs, fat, and protein, and then for marshmallows, carbs, fat, and protein. Now again, you don't really know what organic molecules are, and that is a-okay. You don't need to. But in this case, we're going to look, starting with fats, we're going to go over here to our column of percent fat and see which of these three there is the most of. So Cheetos has the highest percentage of fat. And so the food that represents the organic molecule group, we would say, is Cheetos. Why? Because it has, or they have, more fat than any other food item. Go ahead and finish that up for proteins and carbohydrates. The last part here is then taking the data from a lab similar to the one we did in class and figuring out which organic compound contains more stored energy and how do you know. So first you got to use this data. Which food item released the most energy? Which data did you need to use? And one of the issues that we had was a lot of us wanted to use the calories released, but you can't only use the calories released. And the reason why that is because if we look at this data table, well, the Cheeto does still release the most energy. If we look down here on the mass of the food that burned, this mass difference is how much of that Cheeto burned away, how much of that pumpkin seed burned away, how much of that marshmallow burned away. And we can see here that the least amount of Cheeto burned, the smallest number of grams of Cheeto burned, and then marshmallow and pumpkin seed, each of them burned about a gram of those. So we need to use calories per gram, okay? So we can't only use the calories, we have to figure out how many, if we had burned a gram of each of these, we want to make sure we're comparing, as they say, apples to apples. So we got to make sure we're comparing the calories for every gram burned. So we have to use this data down here. So to get a 4 on this answer, you had to include first which molecule. A lot of people said Cheeto, but Cheeto is not an organic compound, it's not an organic molecule. You had to say which that fats released more energy. You had to include how much energy each item released. So that would have been that calories per gram number. And then last, you had to make sure that you included that connection of the Cheeto to the molecule. Okay, you couldn't just talk about Cheetos and then say that fats release more energy, because if you don't explain why you knew that fat or Cheetos had more fat, then you're missing that connection. Your evidence is not supporting your claim. So what you need to do as you're relearning is simply take your CER, that type answer, and fix it as you're relearning, and turn that into me. Please let me know if you need help understanding this. I'd be happy to help you out. Thanks very much.